All right, we have finally reached the last section here. Really, the easiest thing to do here is to graph in your calculator. I say that because this first one is going to give you a weird looking shape that you are not used to. If you are working on a TI-84, you're going to have to get Y by itself. This is why I do like Desmos, because you don't have to get Y by itself. So what do I mean? When I go to Desmos, if I just type it in as I see it, so x squared minus y squared equals 9. Whoops, that was not equals. It graphs it for me. It even shows me that this is where special things happen. I zoom out and I'm like, oh, what a weird shape. Okay. Spoiler alert, you'll learn about them later. So if I want to draw myself a little sketch here so that if I ever look back on my notes, I have them. And I want to find the domain. Here's what I'm going to do. I'm going to start the very, very left of the screen. So left of the graph is somewhere over here. And I'm just, that point means nothing. That's just where I'm starting. That's what I'm thinking. It's going on forever to the left. Well, forever to the left is called negative infinity. Then where does that piece stop? Well, that particular piece stops at -3 and it is closed. Meaning there's an actual point there. If you remember the term asymptote, there is one, not one. Okay? If you don't remember the term asymptote, that could be because we skipped rationals. So don't sweat it. We'll get you caught up. No worries. Okay, that takes care of the left piece. What it doesn't take care of is the right piece. The right piece is from 3 to infinity. Hopefully you have done domain a lot in Algebra 2, so this is just a review for you. We may not have graphed something this crazy. So there's 2 pieces, so in math, instead of trying to state all of that, of course they've made a symbol for it, and it's just a U shape, meaning union, the joining of, so these 2 pieces. So really, this is my answer, and I should have put it in that box, but didn't for whatever reason, but we'll keep on going. All right, what about x squared plus 4x? Some of you may remember what that looks like. Some of you are saying, hey, that's a function that's going on forever, so therefore I remember my Algebra 2 skills said that when that happens, I already know that a polynomial function is all real numbers because it keeps getting wider as it goes up. Not very fast, it's very skinny, but eventually it gets wider and wider and wider. If you're wanting to sketch, I love Desmos because I literally just touch. I typed something in wrong. I put a 4 up front. Thank you. Okay, try that again. There we go. That's a more accurate. Still a parabola, still widening forever. So the things that I've said are not untrue. It's just now more accurately graphed. So going back over here, -2, -4 crosses at 0 and -4. There's an accurate depiction of my graph. If you recall, there are 2 ways to write this, actually more than 2, but whatever. Negative infinity to infinity. Envision loved to write out the words, all real numbers. I'm going to teach you another one. If you've had me before, you know that I tell you that mathematicians are lazy, so there are shortcuts for everything, including full sentences, okay? So what I'm writing now says the set x such that x is the elements of all real numbers. Amazing that that says all of that, right? So there's symbols. Again, most people end up just doing this. I am also okay with even a shorter shortcut of just making the all real number sign, not even having to put this whole sentence here. So here's what the all real number sign looks like. It is a line, and then another line, side by side, parallel lines. And then a rounded top, as if you're making the paragraph symbol if you were editing a paper. And then a slanted stick to make a capital R. So if you look at just this part, you see a capital R, and it has another part attached to it. So all real numbers, which means it's going on and on and on forever. All right. The next one, in no way would I expect you to have that one memorized. Like, hey, I see that. It looks like, you know, whatever. X squared minus 4. Ooh, crazy stuff happening. Okay, so some 0, 0, it looks like is where it turns. If I look here and I keep zooming in, do you notice that it's not ever actually touching this line that it's getting close to? That's called an asymptote. Same thing's happening at -2. So when I graph that, I'm going to put dashed lines here to be an asymptote, meaning that it never touches it, but it gets real close. So notice here we have 3 different sections, right? So we have starting way left, negative infinity, because we're talking left to right, not up and down. So it's going left forever. So negative infinity. It's going to stop at -2, and it's never going to actually touch -2. So that is a parenthesis because it does not touch -2. But it picks back up on the other side of -2 and stops at 2. Then it picks back up on the other side of -2 and goes right forever. This is a case where it may be easier to write in set notation, because notice that it's actually everything except for 2 things. It can't be -2 and it cannot be 2. So I can write this statement that I just completed here. It says the set of x such that x does not equal -2 or 2. All right. What about the square root of 3 minus 4x? Something special happens right there at 3/4 0. And it goes on like that forever. I did not do a great job because I think it doesn't go through the y-intercept to like 1.5 or something. But for domain purposes, it works. It is going left forever. So we say negative infinity. Up until, where does it stop? It stops at 3/4. Is 3/4 an actual point? Like, can I click it on Desmos and there's something there? Yes. So that means closed. So that's a bracket. If I were to write that in set notation, the set of x such that x, okay, it starts at 3/4 and goes down. Think about that as getting smaller. Well, our word for getting smaller is less than. It could also be equal to, so I'll put a line under it, 3/4. All right, you have completed the notes. So you have one more activity at the end of this slide deck, and then you have a 4-question target assigned as well back in Canvas. So don't forget to submit your slide deck when you're finished, and then to complete the target, and 1.1 notes and assignment will be